Here is our first problem today. Oh, here's our first problem for today. You need to take a look at it. Recognize that in this integral, it's purely algebraic. Know that when trig substitution comes in, you're usually working with something that doesn't have any trig in it. And often you see a square root. And if there is a square root, you see either a sum or a difference of squares. We see a difference of squares. And what we have here is the variable being squared is t. The number being squared is 1. And if you can't remember which trig function to use, think about this. If you have a right triangle, and one of the sides of this triangle is going to be the square root of something squared minus something squared, who's the hypotenuse? And if you want to do a hypotenuse divided by a leg, you are dealing, sorry, I did say that right. Focus, after lunch, trying to get my focus back. Hypotenuse over leg means I'm either going to have to work with secant or cosecant. Which would I prefer? Secant. So that's a way that you can kind of sort through your thoughts if you can't remember how to make the choice. And so I'm going to make the right triangle. So instead of doing something like u equals, we're doing a whole secant of theta equals. And every time we do the u, we also need the du. So we are differentiating, but writing it with just the differentials. The differentials being the d theta by itself, the dt by itself. So everyone, derivative of secant is secant times tangent. And then times the differential d theta. On the right side, what is the derivative of t? 1, and then times the differential dt. Is everyone clear about doing the differentials with the derivatives? You could look at it as you're differentiating with respect to some other variable. And let's say in this case, since we don't have any x's here, we could say with respect to x. If we were differentiating with respect to x, then we would get the derivatives as normal by their variable times their variable with respect to some other variable. But I don't need the differential dx because it cancels itself out. So in a way, it's implicit differentiation. And if you wanted to look at it in a different way, you could look at this as if I was solved for t in terms of theta, I would be looking at dt d theta is equal to, whoops, that was secant, is equal to secant theta times tangent theta, and then the d theta multiplies over. So just a couple different viewpoints of seeing that come out. Now you have to replace your differential And how you go about the rest of it, there are different ways. One way is you can replace all the t's with the trig function. So what I'm going to do is I'm going to put unknown cubed multiplied by square root of unknown squared minus 1. And I'm just going to say that this is times dt because that way I can see a little bit better. dt is secant theta tangent theta d theta. And don't forget, you're going to be turning this in at the end of class. I'll post a homework assignment to turn this in with. So make sure you're doing the work. And then I'm putting the u in, shall we say. I'm going to worry about the issue of the a and the b of the definite integral later. I just want to focus on getting through the integral first. Now take a good look at this, because we could have seen this in a different way. Either we see this as a ratio of two sides of that triangle, or we remember the trig identity that goes with it. Now, if you look at the sides, the root side divided by the constant side gives you tangent theta for opposite over adjacent. So I can replace that whole thing with tan theta. Then the other way, if you didn't notice that route, make sure that you recognize the Pythagorean identity. However, I know that a lot of you don't remember the Pythagorean identity, so let's start again. What is the sine-cosine version of Pythagorean identity? I can get the other two Pythagorean identities if I divide both sides of the equation, and further that means dividing over each term and dividing by either just a sine squared or just a cosine squared. Now let's say we started with dividing by a sine squared. Sine squared over sine squared gives us, and then cosine squared over sine squared, cotangent squared, and then 1 over sine squared, cosecant squared. Does everyone feel comfortable with their reciprocal identities? And I'm just going to make sure, in case some of you don't, you need to make sure you memorize this. And that is secant, cosecant, and cotangent are reciprocals of cosine, sine, and tangent. And if you know your sine, cosine, tangent stuff, then the other three are just found by understanding what reciprocating does. Now, this isn't the trig identity we wanted. The other trig identity is found by, instead of sine squared being divided, cosine squared being divided. So what is sine squared over cosine squared? Tangent squared, and then cosine squared over cosine squared, and then 1 over cosine squared. Realize that as you go into Calculus 3, you need to feel comfortable with your trig. Okay, now as we look at this identity here, can you see that the square root of secant squared minus 1 is actually just tangent theta? So you got a couple ways to do it, either through the trig identity or through the right triangle and looking at the opposite over the adjacent. Now, once everything is substituted in, then it's a matter of simplifying it. And I'm going to first clean it up, right? Secant times tangent over secant cubed times tangent, and then a times d theta. Now, secant is squared, but it's in the denominator. And there isn't like a pathway for it's in the denominator. But what I can always, always, always do is convert everything to sine and cosine by understanding those relationships of these two, and then the fact that tangent is sine over cosine along with this. I can convert everything to sine and cosine anytime I need to. So, what is the reciprocal of secant? Cosine. Okay, now we have a trig integral Now, when it comes to sine and cosine, we're hoping for an odd exponent. If we have an odd exponent, we make u its partner. But if we have an even exponent, what do we do? We bring in a trig identity, and I don't expect you to remember this trig identity off the top of your head. But let's see how much you do remember. Cosine squared is equal to 1/2 times . And I'm going to start with this, and then it's either a plus or a minus depending on whether this was a sine squared or a cosine squared. With the cosine squared, it's a plus. And now I have something I can integrate. So the integral of 1 with respect to theta. And then I need to carefully think about the integral of cosine 2 theta. And if you can do it quick, that is fantastic. I am going to go a little bit slowly just to make sure, because I know people are a little rusty. I need to do a u sub of 2 theta. Du d theta is 2. And multiply the d theta over. D theta is replaced with du divided by 2. And I can bring that 1/2 out in front and then focus on integrating cosine u. Now, when I integrate cosine u, do I get positive sine or negative sine? And I know that's the killer. So I'm getting positive sine. I've got this extra 1/2, and then I put the u back in. Now I'm putting plus c for the moment. And I want to talk you through going all the way back to the original variable right now because of the situation that's here. This is really important for you to know how to work with this situation. Anytime you integrate sine squared or cosine squared, you end up having to integrate cosine 2 theta, which gives you a need to substitute back to the original variable sine of 2 theta, but we don't have sine of 2 theta. We happen to have a nice triangle with a relationship that helps us with theta, but not 2 theta. So anyone think they know where this is going to go? My triangle tells me what's going on with theta, not 2 theta. Trying to get this to move. Come on, move, move, move. I can find sine theta. Yeah.
Isn't there an identity with the sine of 2 theta is cosine theta times sine theta?
Yep. And online, do you remember the identity that can be used in this case? Yep. Sine 2 theta is equal to 2 sine theta cosine theta, and this is another trig identity. I wouldn't expect you to have this memorized, but it should sound familiar. That's going to change this to being 1/2 parentheses theta plus, and then sine theta cosine theta. And now I can use the right triangle. I'm going to distribute the 1/2 while I go through. Anytime you have a lone theta and you need to convert back to the original variable, you want to go to your original substitution. So if I go back to my original substitution, that was that secant of theta was equal to t. So that means inverse secant of t. Then I can use the right triangle for my trig functions. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. And normally I'd put a plus c right now, but this was a definite integral. And it was from root 2 to 2. And I'll show you. Plugging in 2, I need to be able to figure out what is the inverse secant of 2 without a calculator. And understand, if you're going on to calculus 3 after this, you need to be ready to deal with your trig in full, as I've been taking you through it. And as I'm taking you through it right now, you need to be comfortable with it. Right now, I'm just going to plug in the stuff. So I've got my 1/2, and then plugging 2 in here, I'm getting the square root of 3 over 2 times 2, and then minus, I'm going back to my 1/2 inverse secant of root 2. And then if I plug root 2 in here, that gives me 1 over, and then root 2 times root 2. And you need to be ready to deal with simplification. There will be times in third semester calculus that it gets extremely tedious. Now, when I am using inverse trig functions, there are only certain angles I'm allowed to use. If I can manage to stay in quadrant 1, I don't need to worry about it. But for my inverse trig functions, it's either that I am looking from 0 all the way over to pi, or negative pi over 2 to pi over 2, one or the other. And that allows me to only come up with one answer when I do the inverse trig function. So now I'm focusing on what is the inverse secant of 2. The answer to an inverse secant or an inverse trig is an angle. And it's the angle that if I go forward and do secant of that angle, my answer will be 2. And now we come back to who is secant's reciprocal function. And so what I'm going to do is reciprocate the left side and reciprocate the right side. And I need to figure out what is the angle in quadrant 1 whose cosine is 1/2. Cosine are the x values, 1 over 2, root 2 over 2, root 3 over 2. These particular values take me to cutting the quadrant into thirds and then cutting the quadrant in half. This angle is pi over 3. Then I need to figure out what is the inverse secant of root 2. Again, that inverse secant is equal to an angle. I'm looking for what is the angle. When I take its secant, I get root 2. So if I reciprocate both sides, reciprocal of secant is cosine, reciprocal of root 2 is 1 over root 2, and that should look familiar. Does that look familiar? If I multiply the top and the bottom by root 2, I get root 2 over 2. Are you still with me, or are you just ahead? Okay. It's just when I looked out during first period, I saw terrified eyes, and so I slowed down a little bit. Are you all feeling comfortable? Should I slow down? Let me know if there's something I go over and it feels like it went too fast, because I know you guys are living on a COVID version of math knowledge, shall we say. Okay. So basically what this is saying is when my cosine is root 2 over 2, what quadrant 1 angle do I have? Halfway through the quadrant, pi over 4. So now I'm going to do this. I've got 1/2 times pi over 3. And by the way, when you do calculus 3, you have to go back to the idea of being able to simplify. So let's make sure that we can do our math. got? I need to be careful with that subtraction sign. 1/2 times pi over 4. So everyone simplify. Well, darn you, 6 on the denominator. I don't know if that's how you feel.
Wouldn't it be plus 1/4?
Where did I mess up?
You said 1/2 times 1 over root 2 squared is 1/8.
Wait, was this supposed to be a parentheses here?
No, it's just because you have square root of 2 squared and then times 2.
Oh, I simplified wrong. Root 2 times root 2 is 2. 2 times 2 is 4. And can everyone do the whole common denominator thing? I know it's not pleasant, but let's see, 24 is going to be my least common denominator. And then I have 4 pi minus 3 pi plus 3 root 3 minus 6. Woo, wasn't that fun? It wasn't. It wasn't fun. Was it fun for some of you?
It was interesting once we got to the definition part.
Yeah. It's funny. Everyone's got the parts that they enjoy and the, yeah. All right. So here comes another one. Come on. Do what I'm asking. No. I'm not moving the whole thing. I'm moving just... Sometimes I get very, very frustrated. And come on, we can do this. We can do this, my little friend. It always works better when I use the mouse. Okay. This is problem number 2 of today's work. So I'm going to give you a minute to see if you can think about the direction you want to take. And some people aren't working. Or maybe they thought about it already. I see a difference of squares. You know what? I just realized something. This isn't the second problem. At least if I stick to what I did first period. If it weren't for the fact that I already did this with first period, I would just go with that. But now you are a little bit ahead. And we'll be doing that one next anyway. Okay, here we have a sum of squares. Which trig function do we want to use? Tangent. And one way to figure out which trig function should I use is to realize that you need one of the three sides to be all of this square root. The only way you're going to get an addition is if you are adding a leg squared plus a leg squared. So the x and the 16, or the x and the 4 have to be the legs. And that means it's either tangent or cotangent, and we would prefer tangent. And tangent is equal to the variable being squared divided by the number being squared. And it is opposite over adjacent, Pythagorean theorem. And now taking the derivative of tangent is secant squared. The derivative of x over 4 replacing the dx for secant squared theta d theta. And then you have a couple of options. You can look at this as the hypotenuse divided by the side that has the constant. Is the trig function that does hypotenuse over adjacent. And which trig function does hypotenuse over adjacent? Secant. So that square root in its entirety can be replaced with 4 times secant theta. You could have also directly plugged the x in here. And if you'd done it that way, you would have had 4 times tangent theta replacing the x. And do you see the trig identity? Tangent squared theta plus 1 is secant squared. And then I square root the whole thing, and that gives me 4 secant theta. Yeah.
You have to multiply it all by 1/4 to cancel out the 4 from the dx to d theta.
Would I, for this 1/4?
Yeah.
Okay, for that 1/4, I basically, without saying or showing it, I have multiplied it over to the other side.
Yeah, I just remember that in this earlier quick integrals that had if it was secant, if it had a part of it on the dx or d theta or whatever, that we had to incorporate it into the denominator, since we're multiplying by it. Or is it different?
What you might be thinking of is doing a U substitution quickly.
Okay.
That's my guess as to what you're thinking about. Okay, now we are getting somewhere, aren't we? What does this simplify to? And do you remember what the integral of secant is?
max log of secant plus tangent.
Yep. And you want to memorize this. But are we done? Easiest way to convert back to x is to use the triangle. And I'm looking for what is the secant and what is the tangent. And actually, I already know what the tangent is, but I can use the triangle too. And secant is hypotenuse over adjacent. And tangent, opposite over adjacent. Now, this is a possible answer, but I want to talk to you about what else this could be. If you're using log rules, how am I able to play with this logarithm?
It's the numerator and then 2 minus not all of 4, right?
Mm-hmm. Yep. So division inside the logarithm turns into subtraction outside of 2 logarithms. Come on. And does anyone see something really neat that we can do? And this is really important. You may run into a Calculus 3 class where you have multiple choice answers, and I've seen some where they will do multiple choice like letters A through I. And and you have to be ready with whatever format they write that answer in. And recognize that if you have an unknown constant being added, any known constants being added can just be absorbed. And I'm going to put plus c sub 1 just to emphasize that it's not that same c. How was it? Not too bad?
Not too bad.
Okay, excellent. Now, shake this off, and let's get ready for a third problem. And can someone remind me, what time does this class end?
35.
Okay, thank you. If you're online, you need to maybe stand up and stretch. Actually, if you're in person, you can stand up and stretch. It helps because you can only do this for so long before you want, for some people anyway, most people, I should say. I should stand up. Oh yeah, that was needed. I actually haven't stood up since 8:30. Don't you love overcast days? It's a nice overcast day. Okay. Are we ready? All right. Do you see that you have a difference of squares? And do you remember that I haven't so much been always saying variable squared. I've been saying function squared. So if you look at this difference of two things, what function is being squared? Now, when I have this particular order of subtraction, if that's going to end up being one of the sides of my triangle, who has to be the hypotenuse? That hypotenuse has to be the 1. So that helps a little bit. That means that whatever trig function I'm going to use, I need the function being squared divided by the number being squared. And if the number being squared is the hypotenuse, that means leg over hypotenuse. Which two trig functions do I have an option for with leg over hypotenuse? Sine or cosine? And we would prefer sine, but if you want, you can do cosine. And if this is my theta, then opposite and you can see that I end up getting that exact square root if that's how I choose my trig function. And it's a way of knowing that, feeling comfortable that you made the right choice. So once I have u, I need my du. So derivative. Derivative of sine. Derivative of 2x. And I have to replace my dx and then this entire square root, I'm going to have an easier time if I recognize that that square root is adjacent over hypotenuse. So which trig function is it? And if you didn't see that, then you would need to substitute into the x sine theta divided by 2, and you end up getting square root of 1 minus sine squared. All right, now it's a trig integral. Wow. And I have an even exponent on my cosine. So what process do I need to use? I have this 1/2, and then the identity, and cosine is the one that gets the plus. integral of 1 with respect to theta. And then what is the integral of cosine 2 theta? But again, in order to convert back to the original variable, what do I need to do? My triangle knows all the trig functions if the angle is theta, but not for the angle 2 theta. So what's the identity that we need here? Right. So that alone is 2 sine theta times cosine theta times the extra 1/2. And then let's get that right triangle back. But when you see the lone theta, you want to use the inverse of your original u choice. So that means the inverse sine of 2x. And then the triangle sine theta over cosine theta, or times cosine theta, I mean. So my sine theta is 2x. My cosine theta is the square root of 1 plus 4x squared. What? Thank you. I remembered it incorrectly. Minus. And voila. Isn't that exciting? It's a fun puzzle. Realize that if you go into the class differential equations, it's going to make this look easy. But the differential equations class, at least the lower division version of it, you're not having to show the proofs. You're learning a recipe for if you see this, here's the route to take, and it'll all work out. And so you want to feel very, very good with your integration techniques before you go into that class, which, having the BC calculus credit, you are able to go into that class if that's the one you want to take next. Once you have second semester calculus, you can take any of the lower division math classes at that point. So we've got like 5 minutes left. So what I'm going to do is I'm going to come back over here and let's remember, if you have a sine or cosine couple, if P is odd, then you are going to let U be its partner. So if sine is an odd exponent, U is cosine. If cosine has an odd exponent, U is sine. Then let the Pythagorean identity take you the rest of the way. What if you have tangent and secant? if your tangent has, what exponent are we most hoping for with tangent? If tangent has an odd exponent, then we're going to let u be its partner. Meaning u is going to be secant, and then we use the Pythagorean identity. If secant has, what are we hoping for an exponent on secant? An even exponent, then u is going to be its partner. Its partner is tangent, and then use the Pythagorean identity. And the same issue goes with a cotangent cosecant pair. But let me actually add in that some of the beauty of your trig integrals is you could convert everything into sine and cosine. If you really could not remember all these extra little things, you honestly could convert everything to sine and cosine and work with it from there. However, there are certain things that you can run into here that might save you a lot of time. So things to be on the lookout for. What if tangent does have an even exponent? What is a good direction to take? Straight up, just throw in that trig identity. And the bell always stops math classes. When you take math classes in college, you may find that they're always going about 5 minutes over. Because there's no bell to say, stop now. Anyway, hope that was fun.
Thank you, Collector. Have a great day.
You too.